Are you there? Wait, you are there. Are you there? More fun with my pause button. All right, stop it. Let's get serious here. We got work to do. Okay, here we go. It's day 4. Well, I don't know. It's day 34 or something. I don't know. The days, they're running together. It's like a blur. Let's do this. This is episode 4, kids. Pause that video. No, I don't have to say that anymore because I can pause the video. Oh, well, that wouldn't do the same for you, would it, though? Whoa, these issues. Okay, let's do this. Yep, quote by Abe Lincoln. It's actually true. Let's do this one, long division. Oh, let's put this up here so I don't have to keep holding it in my hand. 62. Oh, this is rude. 62,428 divided by 7. This is not the greatest marker, okay? I can't work with this kind of tools. Okay, let's... No. Yes. 8 times 7 is 56. Bam. Subtract. You get 6. Bring down to 4. Daddy, mommy, sister, brother. 7's in the 64. 9 of them. 9 times 7, 63. Subtract. You get 1. Bring down the 2. 7 into 12. That's easy. That's just 1 of them. 1 times 7 is 7. 5. Bring down the 8. 58. Oh, good. It works out nice and evenly. How many 7s fit in it? Oh, it doesn't work evenly at all. 8 times 7 is 56. That's probably going off your page, isn't it? Just about. 2. Let me rewrite my 2 up here. I'm going to add some zeros. Strong wind blows that 0 down. How many 7s fit into 20? Oh, don't forget to put your decimal up there. Okay, that's important. All right. How many 7s into 20? 2 of them. 2 times 7 is 14. Subtract. You get a 6. Next 0. 7's into 60. 8 of them. That's 56. You get a 4. Another 0. How many 7s fit into 40? 5 of them. And now I'm done because I took it out to 3 decimals and that's all I said you had to do. Didn't I say that? Yeah, I did. Right there. I said it. Don't say you were wrong. I said it. You guys don't understand how hard I'm working. Okay. This is rude. The shape. So, what's the value if the x, all those things add up to 19 and you got to figure out the missing hole. Whew, that's rude. Okay. So, we got 6 and a 4th, 3 1/2, 2 5/8, and then just a 4, right? 1, 2, 3, 4, I got them all. Okay, I'm just going to do the whole number parts first, get them out of the way with. Those 2 make 10, those 2 we're at 15. We're holding off at 15. Now we got to add the parts up. 8, 2, and 4. Guess what they all fit into? If you said 8, you said the right thing. If you said 16, you sort of said the right thing. Yeah, you could do that too. But why? I mean, if you said 8,000, that would also be right. But why? All right, let's change all these into 8ths. Hey, that one's already there. Cool, dude. Into 8ths, that's 4 8ths. 8 times 2 is 2. Now I can add them up. 2 plus 4 is 6. 6 and 5 is 11 8ths. So that makes 11 8ths, which is the same as, how many 8s into 11? 1 of them. How many are left over? 3 of them, so 1 3/8. Put these 2 together and I've got 16 3/8, and that's the answer. No, it isn't. The question says the perimeter is 19. So I got to figure out what's left to go from 16 3/8 up to 19. That's subtraction, kids. But it's going to work out. I'm going to rewrite it a different way. Watch how cool I am. Instead of saying 19, I'm going to do 18 8/8. You're like, what's he doing, man? I'm being smart. Watch. Just watch. Okay, 16 3/8. Remember that. What was it? That's right, 16 3/8. All right, now, the reason I did it like this is because, look, 18 minus 16, 2. 8 8ths minus 3 8ths, 5 8ths. Game is over. If I left it as a 19, then I got to deal with all this. I can't, see? I don't, no, you didn't hear that from me. See? Smart. There you go. That's that one. Oh, and I should have put inches. Oh, well. Okay, I'm going to teach you something. 3/5 divided by 3/4. Okay. The book has had you do the same denominator method where you change these guys to the same denominator, in which case it would be 20. Okay? Here's what the rest of the universe does when dividing fractions, okay? The rest of the universe. There's this little bitty dot, which is everyday math, and then the universe. And now we're going into the universe. When you have division with fractions, you copy down the first fraction. You turn the division into an x, which is a times signal. You know, times, multiply. You've heard of it. You've seen pictures. And the second fraction, you flip it. You do the reciprocal of it. You flip it over, which is the 3/4 becomes 4/3. And this works. It gets you the right answer every time. Why does everyday math not teach you? Because it's a trick that works, and they don't want to teach you a trick. They want to teach you some sort of sensible math things. That's why they do about that denominator stuff. But you don't ever have to do it again as far as I'm concerned. Wow. Actually, I take that back. Next year's teacher might not like this, but I'm teaching you. Copy, X, flip. I call it copy, X, flip. Copy, X, flip, copy, X, flip. You copy the first one. You X it, turn the division into an X, and you flip the second one. 3 times 4 is 12. 5 times 3 is 15. That is the answer. Now, you're like, I don't believe you. So let's see if I did the same denominator method, okay? I'd make this into a 20, that's times 4, that's 12. Make this into a 20, that's times 5, that's 15. These fall away. I'd have 12 divided by 15, which is 12/15. You tell me which is easier. My way or the highway, kid. All right, let's do the next one. 3 times 6. Oh, some of you hate these problems. That's actually why I did it. I'm like, oh, they're going to hate this one. All right, let's see if I can do it, because now I've already forgotten what I was going to do. Whoa, you can do it. I think I was going to do 4 minus 1 first, which will get me a 3. But then I wanted to add it to the 2, so I'll do the next series of parentheses there. So now I get a 2 plus 3 is 5. And then I want to do the 6 minus 5, so I have to do another parentheses there. Triple nested parentheses. So now that becomes 3. 2 plus 3, that becomes 5. 6 minus 5, that all becomes 1. 3 times 1 is 3. Boom! Okay. Next. 3.5 times 1 4/5. All right, here we go. What you do is you make them impropers, okay? That's the way I like to do it. That's going to be 7/2. That's going to be 9/5. All right, it's not pretty, but it's going to be okay. 63/10. How many 10s fit in the 63? 6 of them do. They got 3 of them sitting there left over by themselves. Let's put them in a fraction so they feel good. 6 3/10. That's it. All right. And now for the last one. What whole number between 100 and 200? Oh, man, I meant to figure out this answer before I sat up here. I know. I'll hit pause. It took me no time, man. I was right there. Okay, so what I did is I figured out all the squares that are between 100 and 200. It's 10 through 14 all work. And then I figure out what 7 fits into. And that was a little bit of a pain. Not that much. A little bit. I know that 7 doesn't fit into 100. That's gone. I had to figure out that it didn't work by doing a little division. That one didn't work. I know that 20 times 7 gets you 140. And since that's only 4 away, that definitely won't work. This one, do some long division. Grow up. You'll be all right. It's that one. You're like, I don't believe you. Okay, fine. 7. 2 times 7 is 14. Subtract 56. 8. Bam. I'm done, man. I'm so over this. I'm so done with you. Now you're done with math for the day.